All right, let's start. Welcome to another developer community roundtable. And today we are discussing generative AI use cases in healthcare. And I'm very excited to introduce you to Nicholai Mitchko. Yeah, he's a great speaker and has a great experience with this topic. And I was really looking forward to this presentation myself. So I'm giving the floor to you, Nicholai. And after the presentation, we'll have a Q&A time and then just open discussion, right? I'm stop sharing my screen so you can take the floor.
Awesome. So thanks everyone for joining today. I certainly love when a lot of people come out for our developer community events. And really the purpose of this event is to talk about generative AI in healthcare. This is a Zoom, sort of a rerun of this presentation we did in person here in Cambridge, Massachusetts, about a month ago. And during this presentation, I'm going to go into AI in healthcare, what it means and why it's important. And then I'll show you a demo of what AI in healthcare could look like. And so with that, just give me a moment. I will bring up my presentation screen here in a second, and I will start presenting. So just give me one moment here. And glad to see in the chat, people from joining all over the world. I'm glad that we had such good attendance here, and looking forward to a productive presentation. All right. Here we go. Current slide. All right, I will share. All right. So can everyone see my screen here? Around, let's see.
Yes.
Perfect. So this is what I'm going to go through today is really what I call a practical guide of large language models or generative AI in healthcare. I'm going to discuss a little bit about what a large language model is for those who don't know anything about it. Go into some of the use cases. I'll talk about my own personal story and why I actually developed my own large language model. We'll talk a little bit about the hardware, and then I'll show you a real live example, both in a demo as well as as an individual use case we've done with one of our health system partners here in Massachusetts in the United States. So for those who don't know me, I'm Nicholai Mitchko. I run a team of solution engineers or field engineers at InterSystems. And that team is 10 engineers large at this point, and I work in a variety of different markets. So we work with large EMRs, we work with startup partners, we work in financial services. So we've seen a lot of different things when it comes to AI and what people are trying to do. And really, what I realized is that pretty much every one of these markets is looking at how to use AI. And before generative AI, classifier, large neural networks. And then with the advent of things like ChatGPT, everyone is super interested in this. So as this is me, if you want to scan my LinkedIn or join. But as an individual, I study computer science, information systems, and marketing here in Boston. I have experience in a variety of different markets. And particularly my AI experience is in a few different places. The first is with an emotion detection system. I actually did a very early research on emotion detection, where you can actually take a picture of someone's face and see if they're happy, sad, upset, or if they're one of those in-between emotions. Built an email recommender system before large AI. And recently I've been delving into large language models around medicine. So these are actually shared publicly, and I'll go a little bit into this later. But here's what this looks like. So what can machine learning do? You could see me. This is me much younger, much skinnier. In this photo, I'm happy. So the AI worked, and you can see it says 3:15 a.m. in 2016. I was probably happy because finally the AI worked at 3 in the morning. But this is back in 2016, and all the way up till now, in 2023, I've been working on open source medical assistance, where you can ask a large language model, hey, I have an unconscious patient. What step do I evaluate them? And the AI should help not replace a doctor, but confirm or recommend a diagnosis. And this is one of the key powers of AI in healthcare. I'll go into a demo of this in just a moment. But, before we get into that, the big question is, what is a large language model? What is AI in healthcare? And I think the first thing is that it's magic. How can I talk to a computer program and it talks back to me like I'm some sort of expert? How does it know or be able to pass the bar exam or medical exams? This is really, really crazy technology where we can have the computing power to really emulate the human brain. And so, a few key things about large language models are that they're trained on lots of data, typically web scrape data. But at a very high level, all they do is they take some input and give you an output. So the really interesting thing about large language models is it almost brings up a psychological question: is this the same way that our brains work? And in healthcare, there are a few different ways. I think the fastest place that large language models and generative AI can help in healthcare is actually just to manage and mangle all of this large text that we generate, sign-off notes, MRI impressions, you name it. It'll be able to actually read and reproduce and provide sort of synopses as well as machine-readable format based on these large language models in healthcare, particularly around patient notes or dictation. So that's a very, very cool use case where I can go to the doctor and the doctor doesn't sit in the dictation room for 10 minutes. The AI is just listening and will write the notes for me. That is a very, very simple use case for AI to accomplish, can be done today, and would save hours and hours of clinician time, reduce clinician burnout by doing so. So that's one of the reasons why they matter in healthcare. And we're developers here. This is the developer community. One of the questions I always get is, what is a large language model? Well, this is it on screen. Does everyone understand this? Probably not. In fact, I don't really understand all the motions inside of this. But for a developer to use a large language model or even create one, you don't really have to understand how it works. What you should really understand about a large language model is not how it works, but how you create them and how you actually train a large language model. So the idea in a large language model is that everything is text, everything is a token, or everything is a little bit of information. And the idea is that when you think about, whether it's OpenAI or ChatGPT, these AI models are trained on thousands and thousands of GPUs with web scrape data. They have manual edits for the data dumps of public sources like Wikipedia. So we really have to think about, it takes so much power to create a model, but I can run that, on my computer over here. And so when you think about a large language model, just think about all of the resources, if you're thinking about creating your own, that you would need to put into creating a data set and then actually executing that training from a standpoint. But, to really break it down simply, this is how we should think about large language models. They're not magic. They're not, some sort of alien technology. I've heard a lot of theories. Really, large language models, all they do is they predict the next best word. So, at a development meetup, I said, how can I attend developer meetups for free food? What happens is this text, as your input, gets turned into numbers. The model was pre-trained on lots of text and lots of numbers. And all it is a next best token predictor. So text turns to numbers. The model gives us a sequence of numbers that should come next. And then we then convert that back into text. So when you think about a large language model or generative AI, this is how, as developers, we should think about it. It's not this hard, it's not this crazy science that lives up in a supercomputer. All it is I'm taking text, turning it into numbers, handing it to a model, getting some numbers back, and getting text out. The fact that we've been able to trick this process to think, or at least emulate thinking, is a very, very interesting phenomenon. But still, a large language model really is just these few steps. We have some text, and out comes text, but we're kind of tokenizing it, turning it into numbers, and then getting those next best tokens. So if a large language model is just a next best word predictor, I have some graphs on here, don't be scared. What we realized when developing these models is that what the slide shows you is that the more data you give a model and the bigger you make a model, the better it is. And so what these graphs are showing is this is a A, B, C, and D are small to very large machine learning models. And this number here on the left are the percentage of questions, so 50%, 0%, on a trivia question and answer data set that the language model gets right. So trivia questions, something you might see on Jeopardy, something you might see, at a bar when they do trivia questions. What this shows is that as you give it more data, a small model gets okay, maybe does 10%, but a bigger model can get very good. And so this is a really interesting phenomenon where making the process of training smarter or making the model smarter is really just a function of how big can I make it. And so this is a really interesting phenomenon for these machine learning models. And with that background, the next section I'd like to go into is large language models in healthcare. And what I'm going to start with is really the problem space. So some of us may be very familiar with healthcare, some of us not so. But really, healthcare, especially in the United States, but certainly all over the world, has this problem of complex or disparate data, different complex data with a non-standard data model in a variety of different places that are very different. And there's really only one main central point. It's the patient. It's me. It's Nicholai. It's Olga. It's Evgeny. It's whoever is sort of the identity there. And with that, I'm connected to different locations, different clinical trials, insurance, different images, different EMRs, excuse me. And so where can large language models help? Well, we have so many different issues in healthcare and opportunities for improvement if we apply AI to it. And so one of the key things is we can take sort of the experience you have at the hospital and make it personalized. We call this the digital front door, where patients want to be able to ask questions against their medical record. They want to personalize their experience. And I'll show this in a demo just in a second. But this allows us the large language models allow us to tailor the experience using this digital front door strategy, where Nicholai on his phone can ask questions almost as if I was talking to a doctor against my medical record. There are a variety of other areas, but I think the most important area in the United States, and maybe this is the same internationally, is the administrative overhead of healthcare is very large. So I mentioned before that doctors, they sit in a dictation room, which is a note-taking room, after every single patient visit. And they spend more time writing notes every day than they do seeing patients. And so I actually have my own story of this. I had a few surgeries last year on an injury, and every time I would go see the doctor, I would sit in the waiting room, and then I would sit in the actual examination room. The doctor wouldn't show up for 10, 20, 30, 40 minutes. They would show up for 5 minutes. We would discuss all we needed to discuss, and out they would then go to another room where they write all the notes. And this administrative overhead here is about $1 trillion a year for all hospital administration in the United States. $1 trillion is just a ridiculous amount of money. And so if we can use AI to reduce the amount of time and energy it takes to check people in, just coordinate healthcare, and eventually write down those notes, there is a very, very good opportunity in healthcare, especially if you're looking to build a solution around AI. It's to go after all these administrative costs. Not yet do I think that a personal point of care assistant, sort of an AI replacement for a doctor, is the place to start. But certainly, give 5, 10, 20 years, I certainly think AI will catch up and at least be an okay doctor from that standpoint. So with all these problems, what is the industry actually doing with it? Well, here, Google has partnered with the Mayo Clinic in Minnesota in the United States to use their AI model directly as a point of care assistant. And doctors actually say the AI model is better at being empathetic with patients. So if you've ever gone to a doctor and the doctor says, "Hey, Nicholai, go get this lab test done. All right, I'll see you in 5 minutes." Feels very short, not very personal. It makes you feel as a patient belittled. But the AI was saying, "Hey, Nicholai, please go to floor 3. Here are the directions. We really hope that your x-rays go okay. We'll see you back in 15 minutes. That's crazy to think that the doctors are less human than the AI in some point. But certainly this is one part of the industry transformation around AI. Google is investing in this point of care chatbot. Epic and Nuance are investing in automatic note dictation, and Amazon is also creating a service that does automatic notes dictation at the point of care. So, if you're looking to build an application, I have here a model or a reference architecture that you can use. And so if you're familiar with machine learning, there's this concept called retrieval augmented generation, where you have an AI model. You're not going to train it on anything else, but you're going to give it data about the context of what it's being used in. In healthcare, that context could be Nicholai's patient record. It could be how many people are currently scheduled. It could be data about imaging. It could be instructions on how to get to the hospital or how to prepare for a surgery. But the idea is that if you take these steps with a little bit of extra guardrails, some sort of validation or auditing, you can create a very expressive application using AI in healthcare. And the idea is that you would connect to some data source and then create and embed that data in a prompt. And then when you're ready to use it, you retrieve that data and execute it against your AI and machine learning algorithm. Now, it seems very simple. Just store your data, search against it, and include the relevant data. And there are a variety of databases and new software coming out to help this process. But in healthcare, there's one key difference, is that there needs to be very strong validations and auditing around the output. So I recommend that if you're looking to build an AI application, there is always a clinical sort of context or clinical adjudication to any AI suggested or recommended action, because you can't sue an AI model, at least not yet. So you need to make sure that this validation step happens around whatever recommendations you provide. So with that, this is a great architecture for in-context learning, and I'll show you a demo of this in just a moment. And InterSystems has a way to do this as well, which is a way to connect to a variety of systems. And I won't spend too much time on this, but connect to a variety of systems, store it in a data model, and then make it available for large language model processing. That's really not the focus of this presentation. Certainly, if you're interested in how we can help, we could certainly tie this back to after the fact or offline. But certainly there is a model, and excuse my poor PowerPoint drawing skills, but there is a way to create a pipeline for data from a variety of systems for eventual use in an AI model. And so with all that I've discussed, there is a huge impact that you can reduce medical waste, automate data entry, and improve accuracy of care by using large language models. So with that, we talked about so far what a large language model is, the opportunity in healthcare, and how it can help. So I'm going to show you a demo, and I'll talk a little bit about a story that actually comes from my background, which is back in earlier this year, I had gone through a variety of surgeries. And so on this next slide, what you see, this is a real picture. I wasn't posing. I don't remember taking this picture. But what had happened was I had hurt myself in an injury, had surgery to fix it, and then I had a series of infections where I had to have follow-up surgeries and follow-up corrective actions where I had to go basically take go under, and they had to operate on my shoulder. And so I had a really I had a very big issue every time I would go do a test, or I would go do an MRI, or I would go do an X-ray, is that I would take the test. The results would be available to me online in my patient portal, but then I couldn't understand any of it. And so one of the I remember, oops, I had gone too quick here. One of the results had said I had stippled foci of susceptibility. Does anyone on this call know what a stippled foci of susceptibility is? Well, I don't either. And so what came out of this was I needed a way to actually understand my medical record. And it led me down the path of developing my own fine-tune of a clinical assistant large language model meant to answer questions about my medical record. And so the way that it worked, or the first iteration, was based on Meta's Llama 1 and the UAE's the Technology Institute of UAE's Falcon models. So these are open source available models. You can take them and you can actually fine tune it. And fine tuning is the process of adding information to a model or tuning the way that it adds output or the way it responds to an individual. And the goal was that it could answer questions in the medical domain, which adds all this expertise that I had sourced online with various open source data sets, and I can add it into the model. And really my inspiration was this frustration with my own medical text. And so what I do host these online. You can find this on Hugging Face. But it's certainly it does take some hardware to actually run these systems. But what I'll show you now is I'll actually show you a demo of this system using a chat UI that I have wrapped around this model. So if you give me a moment, I'll just change the screen that I'm sharing here, and I'll show you how this works, because this could be very interesting in this retrieval augmented generation, or really basically how this sort of AI system can work. So I'll switch screens here. And what you're seeing here, this is my web browser. And I have hosted here, actually right next to me, I have a server cabinet, a machine learning instance. So this is a simple chat UI. It allows me to put in a message and interact with the model. And in the background, I actually have that same model that I had built, the Med Falcon, that will actually answer me questions about my clinical record. And so one of the things, and I'll just have to open it up here on the other screen so I can show you what this looks like. One of the things that I had done is I had done an MRI impression. And before my latest surgery, I had done an MRI impression. It had said a bunch of things I had no idea about. And so what I'm going to do is I'm actually going to paste that MRI impression and ask questions about it. And so just give me a moment. I'll just open up my, on the other screen, I got to just pull this example up. Just give me, this will just take a second. I've got to find it here. But what you'll see in a second is that the AI does a very, very good job at providing and creating and answering questions about my medical record. And then what I'll show after that is I will show a very, very nice way that the AI, you can actually integrate this using your technology of choice. So just give me 1 second here. My apologies, I should have had this one up. So we'll go a little out of order here. What I'll show you first is actually how you can integrate this very nicely using just arbitrary data types and arbitrary information based on your, whatever you might want to contribute or use as context data for an AI model. And so what I'll show you here, and here it is. Here's a visit summary for me. And don't worry, I consent to everyone seeing this visit summary from a healthcare record standpoint. And what this is, this was after a surgery. After surgery, you certainly go, or you wake up, you have an after visit summary, you have a post surgery or post care plan instructions. And so you're probably exhausted, you go home, you're in pain. The last thing you're probably thinking about is, where is this piece of paper for the instructions? And so what this post-surgery care plan includes are, hey, here are the reasons why you might want to call your doctor. Here are medications you should start taking. Here are the next steps to what you should do. You've got a post-op appointment, etc. And so with all this information that comes out of the medical record, this is in that same model I proposed before, this is our context data. And so with this context data, there is a tool that allows you to interact and create context information basically for any arbitrary AI model. And so what you're seeing on screen, this is a flow loader. It's called LangFlow. And the way you might want to use this with InterSystems technology is that this is all Python based. So you can actually install LangFlow, use this against the InterSystems database using the embedded Python. And what I'm doing here is I've taken that PDF sign-off report, and this flow allows me to load data, this block here, into an AI database, process it using these two steps, and then eventually create a bot that will work against the AI and work against the database in the background that will query my AI. It will query my medical record and use that in the AI responses. And so just before this, I actually had asked a question, which is, what medications should I start taking? And it says, based on the provided context, you should start taking acetaminophen, ibuprofen, and oxycodone, 5 milligrams. Now, that's exactly all the data that came from my medical record. That is used as context when interacting with the AI. And to show you how this might work is I could ask, when is my post-op appointment? And what it's going to do, oops, let's like that. Just rebuild it here. What this will do in the background, this will allow me to go out and interact with the AI model. Oops, maybe if I reload. There we go. Wasn't built correctly. So what this is doing in the background, it's taking in the PDFs from this document. I'll query the AI server. There we go. And what's going back is it's looking for all the necessary context information to include in the query. It's going to retrieve that from the database. And I guess not, maybe it won't. So poor demo, but you saw that the medications, one certainly worked. I can certainly debug this later. But as just a general base AI model, you can certainly do something very similar in using context information. So what you could do is you could just copy and paste in all of your information from your post-op summary. I just copied and pasted this from that PDF. And I could say, based on the above post-op care plan, when is the next patient visit? And what should come back is information based on this context data that will tell me when the next patient visit is. And what you'll see is that the next patient visit is scheduled for Monday, September 12th, 9:15, with Dr. Amy Lynn Brown. What medications should the patient take? And so what I'm teeing up here is that we can actually ask we can ask the AI model any information based on this context data. And you can see that it gets the right medications, it gets the right output, and it will tell you exactly the information. So what is the impact of this? Well, we could use this as a care assistant tool. You could use this as just a question answering bot directly against your medical record, or you can actually ask it to be a better patient. And so one thing that's really cool is I can then ask, what are 5 expert questions the patient should ask about their surgery in the next appointment? And now I, being a better patient, this is actually what I did during my actual surgery. Being a better patient, I can ask my medical record, what questions should I ask in my post-op? And so, for example, how long will it take me to recover? What can I expect to return to work? Will I have any scarring? Is there anything I can do to promote faster recovery? These are all awesome questions that you may not be asking your clinician in your follow-up appointment. And so this not only helps you ask or respond or really use AI in a variety of different ways in the delivery of care, it actually helps patients be better at asking questions and being a better patient within their care. And so I'm going to go back to the slide presentation here. And so, I guess the next best question is, in healthcare, what are the thoughts, or how do we handle the privacy and auditing requirements around these AI models? Well, the biggest hurdle to actually using these AI models is ensuring that a lot of hospitals want their data to be local. So if you want to actually run these machine learning models, that means you have to go out, you've got to purchase hardware to run these AI models. And so what does it actually take to run these AI models? Well, this is actually my home lab. These were pictures from creating, this AI server that's next to me. You need to make a real capital investment in creating AI hardware to run these models locally. And so if you're a hospital, or if you're a developer who needs to ensure their data isn't going out to OpenAPI, it's not, or OpenAI isn't going out to Google, it's not going out to Amazon, then this is probably the next best route to take. And especially in the United States with healthcare, we certainly need to ensure that the data stays local and that there are all the auditing and privacy requirements sort of around these models. And so this is sort of a table stakes. This is something that minimum that you'll need to do is create some sort of hardware or data center that actually can support this. But one of the things, and before I go into the slide, one of the other things that certainly needs to be done in healthcare is you need to audit all the inputs and the outputs to the AI, because the AI can respond differently to the same question with the same context data. And so that's really counterintuitive that a computer program can give you two different answers with the same input. But what happens if I'm a doctor and I want to do one specific procedure? And I ask the AI, what procedure should I do? And I ask it 100 times until it gives me the right answer. This is something that you'd want to log and audit and have the traceability, all the interactions, the inputs and the outputs to the AI that you're using inside your clinical application. So I've got about 5 minutes left here. The last thing I want to talk about before I show this in action in a real world use case is, a very big question, which is the AI hype worth it? There are barriers for adoption. There is a hardware barrier. There is a barrier for not being able to use cloud services. There's a barrier of skills on how to actually properly implement and use AI. But there are some huge opportunities in healthcare if you can figure out those things, particularly around operations and administration. If you can figure out how to reduce operational costs, you can then use a large language model very effectively at improving care. And you can also use large language models for data entry, like Epic and Nuance are doing, where they're listening to a patient visit, tagging who is speaking, and then putting that into the patient notes as a draft. So there is also the problem of who do you sue? And this is a sort of a harsh topic that typically only the lawyers will talk about. But as an AI model, if it gives an incorrect response, who's at fault? And so this takes some thought and sort of it's going to take some thought and a legal framework around it of if the AI recommends something that's not in best practice of care, then whose fault is it? Is it the doctor? What if the doctor didn't know the AI was responding something poorly? But this is going to be a huge topic and a barrier for adoption, particularly with hospitals directly at the point of care. So with that, I'm going to skip ahead a few slides, and I'm going to go down to a real life use case. And this is a real life use case that InterSystems is working on with a hospital called Bay State Health in Massachusetts in the US. And so Bay State Health, as a background, they have a variety of different hospitals that are in the western part of Massachusetts. So the eastern part of Massachusetts around Boston area is very much urban and suburban, very close, high density of providers. But in the western Massachusetts, it's very rural, and they have a whole different set of requirements. And one of the issues they were having was that once they created a patient portal to send messages between patients and doctors, they were seeing that too many people, instead of visiting the doctor, were simply messaging the patient portal. And with that, if you're messaging a patient portal and not actually visiting a doctor, there's a possibility that you have, most of those are going to be generic questions or medical questions, but some of them will actually be real emergencies. So instead of calling 911, these patients are, going to the chatbot saying, help, I have, shortness of breath and I can't move. My chest feels tight. And they're going to the patient portal. So if you have 1,000 messages a day and your patient messages are triaged, how do you ensure that you're taking care of those urgent messages first? And so the idea is that you would use large language models, whether it's GPT or some other large language model architecture, and you would add an urgency flag to the message and be able to sort on this. You can also add a 2-word summary so that doctors don't have to read through an entire message just to get the gist of what someone is asking. And so Baystate had this whole clinical definition of urgent that you could try and write through and create a rule-based model. But with AI, what we had found out is that, and I'll just jump to the results slide here, is that it became very, very easy to take a medical question, and if you could see here on the right, you could take a medical question. We added this box here that says urgent, yes or no. And so what they do now is they actually will go through the urgent messages first, and they've reported a very positive increase in the number of emergencies effectively responded to via patient messages. Moreover, and this is a little small, I know, but over here we actually can see the summary. So you could see right next to the urgent tab, the next thing that Baystate requested was, hey, could the AI just tell us a summary? So with a bunch of sample data, we had proven it out, and now inside of Baystate, they get a sample text, or they get sample text about what the message was that says, hey, this is a COVID bite or multiple medical issues or an appointment, and the urgency flag is also there. So now a doctor or a clinician responding to the clinical messages can respond effectively to these patient messages. So to summarize, and I'll just go to the very end here, is that there are a lot of ways that AI, ChatGPT, different large language models can help. In fact, there's a very famous article, David A. Asher, actually a doctor, had written in the New England Journal of Medicine, who said, hey, ChatGPT, tell me about how you could help in healthcare. And so I'll end here. Here are some of the ideas the AI model came up for itself. But with that, hopefully I provided a nice overview of what AI models are, how they can be used in healthcare, a semi-successful demo, as well as a real-life use case and project that we're working on in a large health system in Massachusetts. So with that, thanks everyone for attending. Olga, I'll hand it back to you.
Thank you so much. I'm just heading to the chat to see if there are any questions there. But I also welcome everyone to unmute and ask Nicholai any questions you might have, or propose any topics you would love to discuss further. Just this is your time to, for open discussion. I do remember we did have a number of questions from registration page. So I'm just giving a minute, some time for you to jump in before I'm just see what we already had.
Yeah, actually, while people type in their questions and think about them, I have one. First of all, Nicholai, thank you so much for such a picturesque introduction or involvement into LLM story with your personal health. This is amazing. But actually, here we have InterSystems developers Roundtable, and of course, maybe one of the obvious questions could be, okay, if I want, can I build my personal LLM with InterSystems Iris? And so, if yes, what would be your advice how to put it?
Yeah, so that's a great question, and so I'll go back to this slide, which shows how this reference architecture. So at a high level, if you wanted to build this with InterSystems Iris, you could take each of these steps and use this either in an interoperability pipeline or write your Python code directly on top of Iris, and then use these specific features here within Iris to perform some of these tasks. And so where our software is really good in this in-context learning pipeline is we're very good at pre-processing and connecting to clinical data in the real world. So for example, I need to connect to a FHIR repository to get the text of my post-op appointment. You can do that in interoperability. We're also really good at storing and constructing that data. And so you can do that in a class or as a database. And then the actual retrieval, we're also very good at being able to, we have a similarity within the product that allows you to do text similarity to get the relevant context information that you might need for your specific LLM queries or your AI, chatbot queries. Where we're making improvements on the roadmap is by next year, we're looking to have a Python API as well as an enhanced feature to do this retrieval, where we actually have a much stronger, in the pipeline, we have a much stronger similarity and vector embedding process that will be coming into the product in one of the next few releases. So that's currently in planning. Where I would say that Iris is not the place is that there is no large language model execution engine. However, we do have an Iris Python runtime. So there's nothing from stopping you from running PyTorch and running your that text UI and the Langflow UI directly on top of an Iris instance on the same server. And so where you might, a general method you might take to connect and add data to an AI model using this in-context learning would be to connect to some sort of interface, store the data, and then get back the relevant data for any particular query using our similarity tools, and then either invoke the AI in Python or invoke the AI via some other API. Typically, those have dedicated servers for an AI model. So Evgeny, hopefully that answers the question and provides a good model for the teams here that are thinking about building AI model based applications.
Well, yeah, thank you. Thanks a lot, Nicholai. And I think we have a question, right, Olga?
Yes. So there is a question from Victoria. She's saying, thank you. It was very well presented. I was going to ask about HIPAA patient data privacy, but you answered it. Do you have any concerns with ethically sourcing data for teaching, training your AI, especially if your data sets generated at your hospital system are too small?
So this is a very, very good question. And so ethically sourcing AI for training is a hard problem with generative AI, particularly what happens if I train on Nicholai's medical record? I don't remove Nicholai, and then I ask the AI, tell me what Nicholai's medical record is. That's a huge problem. The other problem is that there are certainly large tech companies, the Googles, the Microsofts, the OpenAIs of the world, the AWSs of the world, that may have, engaged in data collection practices in the past to train their own AI models. And so there are concerns for ethically sourcing data for training any AI model. And that's why, particularly myself, I'm an advocate for an open data set, meaning that if you're going to train your AI, keep an open data set. However, if your data set is too small at your hospital system, you also have the option to fine tune an AI. So if you're dealing with a particular set of patients, let's say it's always dialysis patients, or it's always diabetic patients, or whatever it might be, you can then fine tune an existing AI model to be very good at solving that one task. So I don't think that data sets being too small in a hospital system to train the AI. I think the most of the users of AI in hospitals or in any healthcare format will take an existing model and use their local data as context and not actually in training the AI. So hopefully that answers your question. All right, any other questions?
Thank you.
Hi, Nicholai. I've got one question. When
go
answering Evgeny's question, you mentioned that Iris will be rolling out vector support, like support for vector databases. Could you please elaborate on that? Like what's coming up?
Yep. So very, very good question. I can't share too much because all I know is that the plan is currently in the works. But the idea would be that existing data, or there would be a new data type in Iris that allows it to have a high performance return for a specific embedding. So this stage right here. So when you process your data, there would be native support to be able to do this embedding and retrieval at a much higher fidelity than just storing it as regular text. And so that does require changes to the product. I do know the best I know about it is that the timeline is to be early 2024 for that to be in the general availability of our software.
Yeah, when I heard about columnar recently, I thought it was something very similar to vector, but
yep. So columnar will be the supporting technology for that vector database.
okay.
So there are a few pieces that just need to be added in to make it, more rounded, but certainly columnar can do that vector similarity to get the retrieval, similar to what ChromaDB does today.
That's great.
Yeah, I have one question. This is Mohammed Wasim. First of all, thanks for your great presentation. It was a wonderful session. Just I want to know which LLM model you have been used in your presentation.
Very good question. I use these two models, Llama 1. I know Meta has released Llama 2. And then I also used, so the one I just demoed to you was actually my fine tune of Falcon. So this is actually running in the background. The Falcon model, you can find it on Hugging Face, and I do host the fine tunes on my own Hugging Face page. So what I'll show here, I was running this Med Falcon V2, which is the same screenshot actually I have from earlier. And this was doing the in context sort of retrieval, as well as asking general medical questions.
Okay, does it require any key, any OpenAI key sort of things, or we can use it?
So this is free and open source. So if you want to use it, you can use it.
Okay.
So there's no key or whatever you need. You would need to have the hardware to support it. So that's the only limiting factor. It does require, I would say, if you're familiar with the graphics card, it requires about 48 gigabytes of VRAM. So in a singular graphics card, so an NVIDIA A6000 or better to run that model, if you're familiar with those.
Are you talking about when we're generating the model, or from the client side when we are accessing?
The client side so from when you use it for inference. Yeah.
Yeah. Okay. Thank you very much.
Nicholai, if you could share the link also, I mean, just not to find it, it would be great. And thanks for this contribution to open source.
There you go. I posted that in the chat. Any other questions?
I think we can just also see how you guys what are you looking for in AI, or do you have current tasks, or maybe you are thinking about how to apply AI in your project, in your work in future, and you can share. And we kind of also will be interested to see your use cases, your possible use cases, and kind of see if that could be solved in the near future, open source or any other way. So if anyone having in mind a certain project they're working on and looking for, I don't know, maybe AI can help, just share with us, any use cases you are thinking about. Victoria saying that I'm thinking about starting to dive into AI development. Do you have any suggestions for where to get started?
Yes, so I have 3 suggestions. The first would be to follow the open source leaderboard for AI models, and I'll put a link in the chat. But what this will show you is a relatively good evaluation of the AI models that are currently released in the open source space. So at a high level, you have an idea of what people are building, where to get the model, and how they're licensed. So that's great if you want to just start using an AI model. You can pick one and then see how it fares against different AI models that are open source. So that's the first thing. The second thing would be to take some courses. There is Amazon and Google both have generative AI courses that will give a pretty good overview of how to interact with AI systems, key considerations to take, and how to properly use them, especially when you start to scale. And then the third would be to check out, there are a few open source projects. If you want to start building your own AI models, we're not talking about just, development against an AI model, but you actually want to create and build your own AI model. You can check out, there are 2 projects. The first one is called QLoRa, and I'll post that in the chat. And this will help you efficiently fine-tune a model. And then there are also courses around fine-tuning, again, from Amazon and Google. So I would suggest taking those courses, looking at the open large language model leaderboard, and then when you're ready to actually dive in and create your own model, to use a framework like QLoRa, which will help you build bigger models on less hardware than requires to run. So certainly those are some great resources to start.
Thank you so much. Any more questions?
Yes, thank you, Nicholai. I just wanted to add for Victoria that if you're gonna look for several examples where InterSystems Iris could be used along with the LLMs, so like ChatGPT in action, you could consider the results of the recent InterSystems Grand Prix contest, where we have a number very good illustrations of ChatGPT usages with InterSystems Iris and Fire, all are healthcare related also, and open source. So, and also I more than happy invite you to our next contest, which is not about AI, but about Python. But again, we encourage you to use Python to build your solutions that will help in digital health and will help to build AI models and use them in digital health. And we have certain bonuses for that. So please, I think this is a good opportunity to also learn and maybe win something, and also contribute to open source.
Yep. So there's another question, which is we saw a clinical demo. How do we see this helping operations, and is ISC doing any work? So certainly the clinical side is cool. But if you can think about the operational challenges that hospitals are currently faced with, you can think about having to compute stars and HEDIS scores, having to do operational and governmental reporting for a variety of informations, as well as just doing administrative and scheduling work that requires a whole army of people to actually review medical records, as well as even things like patient identity. So where ISC is sort of helping in that is that we're working on specific projects with our customers to see how we can automate those using AI models, whether it's taking a whole thing of distilled text and making that very discrete. So their operational reporting systems can take that as an API call as opposed to a human input. But certainly we have focus in both areas. So hopefully that answers that question. And Victoria, looks like you have a question as well. So it looks like Mercy is looking to do message triage, visit dictation, and I'm glad you like the chatbot to ask questions around your own medical record.
Right. We just have only 2 minutes, and I'm gonna wrap it up now. So this session was recorded and will be available on demand. If you have any more questions, feel free to post them on developer community. You have now Nicholai's LinkedIn also. And yes, super excited. Thank you for coming. And see you next time. Thank you, Nicholai, for your amazing presentation, and thank everyone for coming.
Oh, thank you as well. And thanks everyone for attending today.
Thank you. Bye.
Thanks a lot, Nicholai.